Hi everybody, welcome back to our series of videos on the mathematics major. In this video, we're going to look at all of the different concentrations you can choose as part of the math major. Hopefully by the end of it, you'll have a good sense of which concentrations you're interested in, what the heck they even are. All right, let's get started. Let's start with the teaching math concentration. I've chosen that because roughly 80% of our first-time freshmen math majors are coming in believing they're going to be high school teachers. Now, by the time you graduate, that number is going to go down considerably, mostly because you're going to find out we have lots of different concentrations that are very interesting and maybe more in line with what you want to do. However, roughly half of our graduates will graduate with a concentration in teaching mathematics, and a lot of them are going to become high school teachers. So let's start with that. If you want to become a high school teacher, you're going to have to go through a credential program. And so we have designed our concentration to support our credential program. That is, if you go through all the courses you see in this chart, then you are going to be prepared to enter into our credential program. One thing you'll notice is in the bottom right corner, there is a list of courses. They say credential program requirements, and they say EDSC and then a number. So EDSC is the code for our secondary education major. That isn't part of the math department, but in order to get into the credential program, they want you to take these extra secondary education courses. So you're going to want to fill those in somewhere in your path to your degree. As part of the concentration, of course, all these green boxes, those are your core. We've discussed that in the core video. Additionally, there are these two red boxes. You're only going to be taking one of those two courses, and usually that's going to be Math 338. Math 370 is very difficult to get into because it's required of all of the applied math majors. So you're likely going to be taking Math 338, which, although it's not technically a prerequisite for Math 335, we always suggest that you take 338 first. All right, so you'll see the four yellow boxes. Those are all required courses for the concentration, so the modern algebra, mathematical probability. And then at the bottom, you have this 401, 402, which doesn't have any arrows going into it. So it looks like they have no prerequisites, and they don't have direct prerequisites. However, you'll see it also says it requires you to have 12 units of upper division math. So upper division is 300 and 400 level math courses. So usually you're going to be taking 401 and 402 in your final year. That's their intention. They're capstone courses. Those courses are designed to look at the material you'll be teaching in high school, but from an advanced mathematical viewpoint. And finally, there are the 5 white boxes: the combinatorics, number theory, abstract algebra, foundations of geometry, and topology. And you choose 2 of those 5 courses. Typically, I recommend our students take foundations of geometry and either combinatorics or number theory. However, we have students who are taking abstract algebra and topology as well. But I like those particular courses because they go in line with the courses you'll be teaching in high school. Our next concentration is the actuarial science concentration. This is simultaneously the fastest growing concentration in the math department and the one that incoming freshmen tend to know absolutely nothing or the least about. So actuarial science is the mathematics behind, for example, insurance, all right, and, well, actuaries. So what happens is, for example, an insurance company wants to know how much they should charge somebody for, say, car insurance. If they charge too much, then people will just go to a different company. If they charge too little, then when all sorts of accidents start happening and they have to pay out money, they're going to go bankrupt. So they have to very carefully figure out how much money they can charge so that they stay in business, but that they also are going to be able to attract customers. And this, of course, comes down to a lot of probability calculations. There's a great intersection between actuarial science and our probability and statistics concentrations. Uh, there is a huge number of tests that actuaries take in order to get certified at higher and higher levels. Our concentration is designed to help you study for the first couple of these exams. Usually you would then get a job and they would help pay for you to study for more of these exams. Now, what you'll see in this chart is there is, of course, the usual green core courses, and then on the right you have several statistics and probability courses that are required, along with a few courses in white where you're going to choose one of them. On the left bottom, however, you're going to see not math courses. So there are 5 finance courses that you take as part of your actuarial science concentration, 3 of which, incidentally, will fulfill the cognate requirement for the major. Okay, so you're going to choose all those, and then you'll have yourselves an actuarial science concentration, which, I mean, the only thing it's really good for is making a ton of money. So have fun with that. The next concentration is our probability and statistics concentration. Much like the actuarial science concentration, this is a fantastic subject to learn if you want to make a lot of money. So in this concentration, you're going to take a lot of courses in, well, probability and statistics. You can see in the chart, as usual, we have our greens on the left, and then in the bottom right, we have a bunch of courses in data analysis, stochastic processes, mathematical probability. You're going to use a lot of computers because you're going to do programming. In particular, in addition to MATLAB, which we typically learn at the lower division level now, you're also going to be learning about R, which is a statistics software, and very likely Python, which is a more general programming software. If you're interested in working with computers more, this is a fantastic concentration. It's a very marketable concentration for you, and you'll get a lot of mileage out of it. All right, our next concentration is the applied mathematics concentration, which is actually split into 2 parts. And so right now we're going to talk about the modeling and computational applied mathematics concentration. So in this concentration, much like probability and statistics, you're going to be using a lot of computers. You're going to be solving real-world problems and are going to be very marketable when you're done. Big difference here is whereas probability and statistics focuses on, well, probability and statistics, the modeling and computational track tends to focus more on linear algebra and differential equations as ways of solving real-world problems. Now, if you don't know what those are, that's okay. That's why you're here. Differential equations are ways of modeling how things change over time. So much more precise than the statistical methods, which are really asking, what is the chance that something is. Differential equations there's no chance involved with them. They're really just trying to model if something is changing over time, what is it going to look like in 1 second, 1 day, 1 year, etc. So this is what's used, for example, when studying things like climate change or trying to predict where you're going to have a greater chance of crime within a city, etc. We have a tremendous number of new young faculty in this group, and you're going to have a lot of fun taking courses with them. All right, the next concentration is the pure math concentration. This is near to me since I teach in the pure math concentration. Unlike the previous concentrations, pure math isn't intended to solve real-world problems. It's meant to solve mathematical world problems. Now, before you run away to the next concentration, you need to understand the other concentrations, even though they may not always want to, they use the math that the pure mathematicians come up with. Also, this is by far the most difficult of the concentrations. It's very abstract mathematics. It's hard sometimes to see how it can be applied in the real world. However, it's also the most fulfilling concentration. If you go through this concentration, you are ready to tackle more or less any challenge that's out there. Yes, you can go on to graduate school with a pure math degree, But you can go into the workforce. You can work in business, industry, government, and when they see that you have pure mathematics skills, you are immediately going to be, in almost all instances, the smartest person in the room. Most of my pure math students who have graduated and did not go on to graduate school, within a month of wherever they go, realize they can do more than anybody else in their company or their unit. And they've progressed very, very quickly through the ranks because of that. So what's going on in this concentration? Again, we have the core. Down below, you have 3 yellow courses. Those are all required. So you have an algebra course, topology, and a sequel to the advanced calculus course called Advanced Calculus 2. And then there's a list of 5 white courses, of which you'll take 4 of those: combinatorics, number theory, abstract algebra, differential geometry, and complex analysis. So I won't go into what all of those different courses mean. I'll just say they are all courses based on material which started as something very abstract and pure, and all of them now have been used to solve real-world problems. So don't get fooled into thinking that pure math is only for people who want to go on and get a PhD or who want to teach math. Lots of people who get a pure math degree go on to have very successful careers in business, industry, and government. All right, our final concentration is also within the applied mathematics, and this is the other track I referred to earlier, and it's called the classical track. So this is essentially a variation of the pure math major, only it spends a lot more time on the theoretical side of differential equations. So as I mentioned when we talked about the applied math concentration, one of the big differences there was that you use differential equations and linear algebra to solve real-world problems. In the classical track, you're looking at the linear algebra and the differential equations, but from a more theoretical point of view. So if you go back and look at the courses that were required in the pure concentration, and now here in the classical, you're going to see a lot of overlap between them. The big difference being ordinary differential equations, partial differential equations, vector and tensor analysis. 3 courses not in the pure track, and which are more of an applied bent. Right? However, I still always think of this as more of a pure concentration. Very, very powerful math that will prepare you for just about anything you like. Okay, well that is our trip through the concentrations of the math major. I hope you have a better understanding of what those concentrations are all about, and I hope this has helped you make some sort of a decision on what you'd be interested in taking. All right, we'll see you in the next video.